Welcome to Lake Forest, California. This is test 2 of a rocket-powered boat. Got a little high-tech today, and the boat I'm going to be using is a carbon fiber Starship, normally electric-powered, 3 cells, nice speed controller. But today I've removed most of that, with the exception of the motor and the servo. And for propulsion, I'm going to try something a little bit different. This is a dual rocket engine setup that I built for the top of it. The canopy fits right on the top of it. The motors are C-class motors, each one of them putting out 2.7 pounds of thrust for a total of 5.4 pounds. Now this is pretty incredible because the whole Starship with the propulsion system onto it weighs 1.2 pounds. So that gives us a thrust to weight ratio of 4.5 to 1. 4.5 to 1. Now, what does that really mean? The F-22 Raptor, 5th generation stealth fighter aircraft, Mach 2, produces about 35,000 pounds of thrust. And that 35,000 pounds of thrust is matched by its weight of 35,000 pounds, giving you a ratio then of about 1 to 1. A little bit different than the 4.5 to 1 that I have here. But that's not all. When we think about it, we have another option, and we could put even higher rockets on. The next rocket then that I'm considering, if these tests go well, is a rocket then that will actually provide twice the power. And this is it right here. So this is going to give me twice the thrust out of that, which is a total of 10.8 pounds, giving me a thrust ratio to weight ratio of an incredible 9 to 1. So that's 900% more than an F-22 Raptor. Interesting. Let's get ready for the test. The activation of the rockets on my carbon fiber Starship is going to be accomplished by a small remote control system. It's independent of the normal RC control system. This one has 4 relays. I've set it up so the contact can be momentary or latching. It's powered by any source, 5 volt. In this case I have a 9 volt battery. You can use a 12 volt battery. And in one of them I have plugged in a small little speaker. So just to show you what it does with my remote control unit, I plugged this into channel 1, so you should have hear a beep when I hit it. That would indeed activate both of the rockets. Now, there is another type of remote control I use, a little bit smaller. It still has 4 channels connected with it, and I can do the same thing. Hitting one of the buttons for that channel activates the sound. Now, this is a rather large overkill for this little application, but I want to do some other things. If I just wanted to do that, I could use a single channel unit, so you can see how much smaller this is. The relays on these will handle 10 amps each, at anywhere up to about 15 volts and down to about 5 volts. The antenna that you see is used at a frequency of about 315 megahertz. This is all FCC approved, and of course our plug comes into the battery. Now if we really wanted to go small, because the bulk of this is in that high amperage 10 to 15 amp relay, this is the small module. And this is actually a 4-channel remote control module that can also be used for current capacity up to about 100 milliwatts. So we have a wide diversity then of remote control units, 4-channel, 1-channel, ultra miniature 4-channel, and a wide variety of controllers, anywhere from 4, 8 channels, smaller units in which look like a little garage door opener. In addition to the control system, I have something else that I'm going to put inside of the Starship. You'll notice that there is some Velcro on the top. I have a miniature GPS data logger. So the data logger, this is the antenna side, will go on there. This is why I'm using the fiberglass top rather than the carbon fiber for GPS signal penetration. That in turn is powered by a small independent battery. The connector that you see here is fed into my remote control, so I will take what was my little speaker out, and then I will plug this in and put the control unit into the bow of my new Starship. In this close-up, you can see that my fuses have been set inside the rockets. My activation lines fed through a waterproof connector down into my controller. I'll be using channel A. That will go in the bow of the boat along with my 9-volt battery, which will be connected to this battery snout. So at long last, it is time to launch. We have a slight wind that has picked up here, but the boat seems to be ready. Now kids, don't try this at home. I've got to see if I can get this lined up to where I want to go. I have my control unit here, so let's make sure it's working. Hear the beep. Okay. 5, 4, 3, 2, 1. And we've got no ignition. No ignition. Can you believe that? The batteries are not strong enough to actually generate the current required for the little igniters. So this is phase 2, going back and putting a 12-volt battery rather than a worn-out 9-volt. End of test.